It's another day. It's another day to deal with the beautiful subject of chemistry, but this time alternative to practical for the general certificate examination. I am Adeyemi Abiodun, the lead tutor at 300 Plus Academy. Okay, do well to check us out on our website 300plusacademy.com, where you can link up with your peers writing same exams. You can exchange academic materials. You can ask us questions for clarity on gray areas. Okay, also do well to subscribe, turn on the notification bells, like, share with your peers, and of course comment on the lectures. Okay, let's get right into it. We have a probable question for you for the chemistry alternative to practical GCE examination. As you can see displaying on your screen, it talks about a titration question, an acid volume 11.30 cm cube containing 5.3 gram of HCl per dm cube. In other words, we've been given the mass concentration of the HCl there, 5.3 gram per dm cube, reacted with 25 cm cube of a base containing 1 gram of sodium hydroxide. We were given the equation. From the information provided, we were told to calculate A1. As you can see on your screen, A1, the concentration of the base in mole per dm cube. Of course, this is a very direct question. We were given the concentration of the acid. So, since we have information about the acid, that becomes our standard solution. And since we do not have any information about our sodium hydroxide, it means for now the sodium hydroxide is not yet standard. So what we're going to be doing here is that we will use the acid, which we know the concentration, to standardize the base, which we do not know the concentration. In other words, we will use the standard solution, which is the acid, to decode the concentration of the base. So looking at that, A1 says we should find the concentration of the base in mole per dm cube. Very easy. The volume of the acid here, is 11.30 cm cube. That's talking about question A. As you can see on your screen, the volume of the acid here is 11.30 cm cube. The volume of the base here is the volume of the pipette. The volume of the base here is the volume of the pipette, which is 25.0 cm cube, as given in the question. Okay. When you look at the reaction, number of moles of the acid, Na is 1, and then Nb is also 1. Okay. We were told to look for the concentration of the base. Yes. That becomes my question. And for the concentration of my acid, okay, based on what I have there is 5.3 gram per dm cube. 5.3 gram per dm cube. Of course, I want to take this to mole per dm cube, so that what that will mean is that my concentration in mole per dm cube is actually concentration in gram per dm cube divided by the molar mass, and here that means 5.3. Yes, that's what I have from the question. 5.3 divided by HCl, because my acid is HCl, that is 36.5. My acid in this case, my A in this case, is HCl. As you can see on your screen, 1 plus 35.5, 36.5. If I compute this, 5.3 divided by 36.5, that is 0.145 mole per dm cube. So having this, I can then deal with my base. You know, you recall the formula is Ca Va over Cb Vb equals to Na over Nb. What that means is that Ca Va Nb equals to Cb Vb Na. Then my VB-Na will come here. So that means my CB equals to CAVA NB divided by VB-Na. So what I have, my Ca is 0.145 times my Va is 11.30. My NB is 1. My VB is 25. And my Na is 1. So computing this, my CB equals to 0.0655 mole per dm cube, 0.0655 mole per dm cube, and that answer question A1 CB. Now value of Y is the next thing I was told to look for. If you look at the question displaying on your screen from the beginning, 25 cm cube of a base containing Y gram of sodium hydroxide per dm cube, telling me to calculate the value of Y too. Telling me to calculate the value of Y here, telling me to calculate the value of Y simply means concentration of the base in gram per dm cube. Yes, look at the question very well. Base containing Y gram of sodium hydroxide per dm cube. So that comes very easy. Concentration in gram per dm cube is actually concentration in mole per dm cube times molar mass. My Y in this case, what we are dealing with is sodium hydroxide. So if we calculate the molar mass, it is actually 40. Just take note of that, so that my concentration in gram per dm cube is actually concentration in mole per dm cube 0.0655. 0.0655 times the molar mass is 40. If I multiply this, computing this, I am going to get 2.62 gram per dm cube. Yes, 2.62 gram per dm cube. So that is the concentration of my base in gram per dm cube, and that represents the value of Y. Moving forward, question A3, it says, what is the mass of sodium chloride formed during the reaction? Recall that from the question we said reacted with 25 cm cube of base containing Y gram of sodium hydroxide per dm cube. So you're looking at mass of sodium chloride formed during the reaction. Of course, this is purely stoichiometric. Okay, this is purely stoichiometric, where you have HCl reacting with sodium hydroxide, okay, to give us sodium chloride plus H2O. Okay, taking a look at this from the beginning of the question, as you can see, 25 cm cube. 25. The volume here was 25 cm cube. Okay, and from this volume, you look at the concentration that we had calculated here. The concentration was 0.0655 mole per dm cube. So that the mole here for this, the mole here, the mole is actually concentration times volume. This is 0.0655. But of course, this is in cm cube. That will be 25 divided by 1,000. Yes, 25 divided by 1,000. So if you compute that, that's going to be 0.0655 times 25 divided by 1,000. That's going to give you 0.00164 mole. The mole here is 0.00164. Yes, 0.00164 mole. That is talking about my sodium hydroxide, because why I said this is purely stoichiometric is 1 mole of sodium hydroxide is equivalent stoichiometrically to 1 mole of sodium chloride. So if you say 1 over 1, 1 over 1, then 0.00164 mole of sodium hydroxide should give us what? Mole of sodium chloride. Like 1 to 1, the mole of this divided by mole of the sodium chloride. Recall that we are looking for the mass of the sodium chloride. So what I have here is that the mole of the sodium chloride is going to be 0.00164 mole. Having said that, we were told to look for the mass. So recall that mole equals to mass over molar mass. Therefore, mass equals to mole times molar mass. The mole here is 0.00164. The molar mass for sodium chloride, sodium is 23, chlorine is 35.5 as given in the question. You take this together, that will give you 58.5. 58.5 you have. You multiply this together, you're going to get 0.0959 gram. 0.0959 gram. Yes, that is the mass of sodium chloride formed from 25 cm cube of sodium hydroxide as you have in the question. So that answer question A3. Moving on to question B, we're looking at, okay, now talking about question B, we were told to state the indicator that can be used for this reaction. Of course, this is a reaction between a strong acid, that's talking about my HCl, versus a strong base, talking about my sodium hydroxide. So we can use any indicator, but let's say we want to make use of, we can use any indicator, but let's say we want to make use of probably methyl orange. Let's make use of, okay, for this B, we can actually use any indicator. You can use any indicator, but what the question was, state the indicator that can be used for this reaction. If we are using any indicator, okay, let's say we want to use methyl, we can use methyl orange, we can use phenolphthalein, why phenolphthalein? Because it's a reaction between a strong acid and a strong base. And in fact, we can also use methyl red if we want. We can use methyl red. We can use methyl red. But what else do they want? That's for B1. State any indicator. B1. For B2, they said state the color of the indication mentioned at the end point. At the end point. At the end point, we should state the color of the indicator at the end point. Now, B2, what will be the color of methyl orange at the end point? If you write orange, okay, you'll be correct. If you write pink, you'll be correct as well, depending on how you look at it. So we're looking at what will be the color of methyl orange in this reaction at the end point, orange or pink. Okay, talking about phenolphthalein, that is going to be colorless at the end point. And talking about methyl red is going to end up being red at the end. Methyl red ends up being red at the end point. Methyl red ends up being red. So that ends B1, B2. Okay, and that ends that all of these for 18 marks or 20 marks thereabouts. So it is not every time that we have a titration that we must have a table. No, we necessarily do not, you know, need a table in this regard. So if you check most of the probable questions we've brought forward, we've not had any table thus far. So with this, we've come to the end of this probable question for your chemistry alternative to practical GC. Do hit the subscribe button, share with your friends, comment, like, and turn on the notification bell. For me to you, it's bye for now.